Welcome, guys. Math in the Modern World. In this lesson, we will discuss all about mathematics as a study of patterns and relationships. Mathematics is the science of patterns and relationships. Patterns provide a sense of order. It allows one to make an educated guess. A lot of disciplines are based on making hypotheses, and hypotheses are often based on patterns. Assumptions are also based on patterns, recurring patterns. Thus, the understanding of patterns aids in the development of mental skills needed in the transformation of ideas to information, then to knowledge. So how can we understand the pattern? Yun ang ating pag-aaralan in this lesson. In order to understand, we must recognize or we must learn how to recognize patterns. Now, in order to recognize patterns, one needs to have an understanding of critical thinking and logical reasoning, important skills needed by everyone. These are major components in problem solving and is involved in data analysis. Okay? So, para daw natin ma-recognize ng mabilis ang isang pattern, ay let's study yung mga common patterns na nag-exist na. Number one, we have the logic patterns. No? Logic patterns are related to geometric patterns and number patterns. It helps us classify objects or figures. One kind of logic patterns deal with characteristics of various objects. Another kind deals with orders. There is a sequence of objects and a pattern in the attributes the objects possess. They are commonly part of aptitude tests. The development of numeracy literacy and geometric literacy follows after one develops a sense of patterns involving logic or reasoning through association or through relation. So what do we mean by that? For example, in this polygon, a diagonal connects two vertices that are not already connected by an edge. So pag sinabing vertices, yung kanyang dulo, yung corner, yung mga hindi pa raw nako-connect ng edge, no? So we connect them and we form a diagonal connections, no? The same way with the shapes. Okay, if we connect the vertices, then we can have this star shape, no, inside this hexagon, no. So how many diagonals can be drawn in a hexagon? So we have one, two, three, four, five, no. 2, 4, bali 6, no? 6 diagonals. Sa rectangle naman, we can draw 2 diagonals, no? So 1, 2. In example 2, if we look at the pattern, okay, how many circles daw will be in the next figure in the pattern? So anong sagot natin dito? So itong circle na to na doble at itong dalawang circle na to na doble nag plus 1 pa. Okay? So sa pattern na to, itong lahat ng circle na to, bilangin mo at mag-plus ka ng isa, yun ang kasunod na bilang ng circle, no? Na para sa pattern na to. So if we have 13, so we double it. So 13 times 2 is 26 plus 1 kasi yung dalawa naging karoon ng isa. So plus 1, we have 27. So answer natin dito ay D. Next pattern, we have the number patterns. It is a list or set of numbers that follow certain sequence or pattern. As an arrangement of number, it illustrates a way that it follows a particular property or pattern. When numbers are arranged in either ascending or descending order, and evident basic operations of mathematics are certain series of arithmetical operation like addition or multiplication repeatedly done. No? So there are different patterns when it comes to number patterns. No? Patterns can be in the form of counting up or counting down, and the missing number is of the form of completing the count up or down. No? Like 1, 5, 9, 13, 17. Okay? So ascending siya, whose first term is 1 and jumps 4. No? So 1, nag-plus ka ng 4, naging 5. Nag-plus ka uli ng 4, naging 9. No? So it's basically, kung i-analyze mo yan, we have 4 here, we have 4 here, we have 4 here, and we have 4 here. So, adding 4 is the pattern, no? Some other types are created in which every successive term is multiplied or divided by the same value each time. No? For example, 4, 16, 64 is a number pattern in which 4 is the first number and we can multiply 4 by 4. No? So each term is multiplied by 4 in order to get the next term. Okay? This number pattern is called a geometric number pattern. 32, 16, 8, 4, 2 is again a geometric pattern in which the fixed number is 1 half. So pababa naman siya, meaning descending, which is computed or arrive at by getting the 1 half of the number, no? Preceding the next term. So 1 half ang ating multiplier. There are other number patterns. There are patterns in which the numbers are in decreasing form. In this pattern, the amount that is added in the term changes every time in a predictable manner. For example, 4, 5, 7, 10, 14, 19. In the above pattern, the pattern starts with 4, add 1, and the amount which we can add increase by 1 every time. So, let's say 4 plus 1 plus 2 plus 3 plus 4 plus 5. So, kung itatanong sa atin kung anong kasunod niyan, alam na natin ang kasunod. Anong kasunod niya? 25. Okay? Dahil ito ay 6. So, 19 plus 6 is 25 ang kasunod. Okay? So, this is also a type of number pattern but they are in a increasing form. Other types are of the nature of the well-known Fibonacci sequence. O yan, ito yung na-discuss natin before. The Fibonacci sequence is a series of numbers where a number is found by adding up the numbers before it. Okay? So one of the most interesting number pattern is the Pascal's triangle, named after Blaise Pascal, a famous French mathematician and philosopher. To view the triangle, start with 1 at the top and then continue placing numbers below it in a triangular pattern. Each number is the numbers directly above it added together. So, ang pattern niya is 1, 1. So, wala tayong i-add. So, just copy the 1, no? But here, i-add natin itong dalawa. 1 plus 1 will get 2. Okay? Also here, 1 plus 2, we get 3. 2 plus 1, we get 3. 3 plus 3, we get 6. 3 plus 1, we get 4. 3 plus 1, we get 4. So on and so forth hanggang marating natin tong ibaba ng pyramid. Okay? So let us consider 1, 8, 27, 64. Here we can find the next number as follows. So ito naman, in-analyze natin to. We can figure out by converting it into exponential form. No? For example, 8 is also equal to 2 to the third power. 27 is 3 to the third power. 64 is 4 to the third power, and so on and so forth hanggang mahulaan natin or ma-derive natin yung kasunod niya, which is 5 to the third power, which is 125, and 6 to the third power equals 216. No? Kasi makikita natin dito ang lahat ng number na to which is ascending, no, by 1, 1, 2, 3, 4. Nilagyan lang natin ng exponent, no, na 3. So ang kasunod niya is 5 to the third power and 6 to the third power, no? We have an example here. Find the next number in the pattern: 45, 48, 51, 54, and 57. So given the pattern, we have the following solution, no? Here the pattern is a repeated addition of 3. Okay, repeated addition of 3 kasi 45 plus 3 is 48 plus 3, 51 plus 3, 54 plus 3 is 57. So, ang kasunod niya, yung nawawala, is 60. Okay? So, ito yon. In the problem, 6th term is 60 in this pattern, which is the missing term. Example number 2, find out the missing number in the pattern 67, 74, 81, 88. And our answer is 102. Why? Hindi pala yan, no? And the answer, ang ating answer is 95, no? I-analyze natin. The missing term in the above pattern is 95 because of the repeated addition of 7. So 7, 67 plus 7, 74, plus 7, 81, plus 7, 88, plus 7, okay, 95, yun ang ating sagot, plus 7, 102. Okay? Example number 3, what is the next number in the pattern? 108, 102, 96. So the answer is 90. Why? Because we have an ascending sequence which is formed by subtracting repeatedly by 6. No? So 108 minus 6, 102 minus 6, 196 minus 6 will give us the next term. Another kind of pattern is the geometric pattern. A geometric pattern is a kind of pattern formed of sequences of lines and curves to form geometric shapes and figures. No? A motif, pattern, or design depicting abstract non-representational shapes such as lines, circles, ellipses, triangles, rectangles, and polygons. So ito yung example natin. Determine what shape, figure, or series of figure would follow the sequence. So una muna, black square, then it is followed by white square, then followed by the black square. So ano daw ang kasunod nitong pattern na to? Of course, obviously, ang kasunod niya ay black square dito. Okay, mga black square. Ito naman, obviously, ang kasunod niya is another set of stars, square, and circle. Okay? Example number 2, draw the missing figure in the sequence. So, manotice nyo, triangle, square, and then ano to, hexagon, no? So, 3 sides, 4 sides, 6 sides. So, ibig sabihin, kailangan natin mag-drawing ng 5 sides, no? 1, 2, ay, sorry. 1, 2, 3, 4, 5. Okay? So, yan ang ating sagot na shapes. And those are the types of patterns, no? Okay, we will go now in lesson 1.3, which is mathematics in nature, no? Euclid said that the laws of nature are but the mathematical thoughts of God. Galileo affirmed by stating that mathematics is the language in which God has written the universe. Okay? Knowing that principle or knowledge, we can deduce or we can conclude that mathematics is everywhere since we believe that God is everywhere. No? It is in anywhere in the universe. With the development of a formal system of thought for recognizing, classifying, exploiting patterns, one could systematize and organize these ideas of patterns. So ano tong mga patterns na to? We have number 1, shapes. No? Geometry is the branch of mathematics that basically describes shapes and establishes the relationships between them. Figures with regular shapes are categorized as polygons. Polygons are fascinating, especially when they are approximated in nature. Okay? So we have spatial patterns that can be represented by a fairly small collection of fundamental geometrical shapes and relationships that have corresponding symbolic representation. So ano yung example nun? We have lines, planes, triangles. We have also points. Ito, squares, circles, and ellipses. Rectangular, solids, spheres. Yan ang ating mga example. No? Both shape and measurement, magnitude, or scale can have important consequences for the performance of systems. Na pag sinabing magnitude, yung kanyang lawak. Yung scale niya is yung kanyang lalim. No? For example, triangular connections maximize rigidity, smooth surfaces minimize turbulence, and a spherical container minimizes surface area for any given mass or volume. So lahat naman ng shape ay merong attributes, merong properties, may kanya-kanya silang measurements, no? Ito yon, magnitude and scale. Ano yung common shapes natin, no, na visible in nature? We have sphere. Sphere is a perfectly round geometrical object in three-dimensional space, no? So iba ang sphere sa circle, no? Pag circle, 2D lang siya. Pag sphere, ito 'yon, no? Three-dimensional. Hexagon is a six-sided closed polygons, two-dimensional. Yan, 2D, no? Two-dimensional. Si cone naman, siya ay three-dimensional, geometric shape that tapers smoothly from a flat, usually circular base to a point called the apex or the vertex. So, yun yung vertex niya. Ito yung kanyang base, no? Which is a circle. Parallel lines, no? In mathematics, parallel lines stretch to infinity, neither converging nor diverging. So, ito yung example natin, no? Pag sinabing parallel lines, yan. Pareho sila ng direction, no? Hindi sila nagko-cross. Another pattern is the symmetry. No? Symmetry is a type of invariance, a property that something does not change under a set of transformations. So it is a mapping of the object onto itself which preserves the structure. Symmetry in everyday language refers to a sense of harmonious and beautiful proportion and balance. So we have the two kinds of symmetry. One is bilateral symmetry, in which an object has two sides that are mirror images of each other. The human body would be an excellent example of a living being that has bilateral symmetry. We have also what we call the radial symmetry. No? This is where uh, there is a center point and numerous lines of symmetry could be drawn. The most obvious geometric example would be a circle. Patterns, though every living and non-living thing of the world may seem to follow a pattern of its own, looking deeply into the geometry and mechanism of pattern formation can lead you to broadly classify them into merely two categories. No? So, yung pattern daw, no? We can categorize them, no? Into two. Self-organized patterns or inherent organization, and last is the Invoke Organization. Under ng self-organized patterns, it follows a simple set of rules and they use only local information to determine how a particular subunit evolves. So, ano example natin? Ito, okay, mga self na organized, no? So self-organized organization is a process in which pattern at the global level of a system emerges solely from numerous interactions among the lower level components of the system. So therefore, if rules are to be useful for understanding the patterns in life, such as the stripes on a zebra's coat, there must be a specific rule. So, lahat na nakita nating pattern sa nature, no, ay may pinapalo daw na rule if we consider their self-organization or what we call the inherent organization. Okay? Under naman ng Invoke Organization, not all patterns that occur in nature arise through self-organization. A weaver bird uses its own body as a template as it builds the spherical or hemispherical egg chamber of the nest. A spider, when creating a web, follows a genetically determined receipt in relation to its sticky orb. No? So ito yung B, no? Example. No? So ito ay example ng Invoke Organization. Bakit? Because it is inside their DNA, no? So it is genetically determined, okay? So hindi naman sila nag-iisip, okay? Nasa genes na nila ang gumawa ng ganitong pattern. That's why it is considered as an example of Invoke Organization. Another example is the spider web, okay? The insect architecture, the wasp nest, an example of Invoke Organization in nature. So more than this biological system existing on the patterns created in nature, there is a great mathematics embedded in it aside from the plain geometric figure. Okay? So, yung in-explain natin about the Fibonacci numbers, they are under or included as an example of Invoke, no, organizations. Also the golden ratio, no? So sino yung sabi natin gumamit ng Fibonacci or uh, nag-introduce, no, ng Fibonacci number pattern, no? Si Leonardo Fibonacci, no? Who began the study of this sequence by posing the following problem in his book. Sa libro niya na ang pangalan or ang title ay Liver Abazi, How many pairs daw of rabbits will be produced in a year, beginning with a single pair? If in every month, each pair bears a new pair which becomes productive from the second month on. So, kapag sinold mo raw to, makita mo yung pattern na 1, 1, 2, 3, 5, 8, 13, no? In which, if we use the functional notation, we can write Fn equals to f of n is equal to f times n minus 1 plus fn minus 2. Okay? So, yun yung dalawang pair na sinasabi dito sa problem, no? Which is numerically, ito yung kanyang pattern, no? Dalawang pair, pinagsama mo, will result in a second pair, and this second pair will result, no? After 2 months, after the second month, no? In another pair plus 1. Okay? So, kapag daw kinuha natin ng ratio nito, it will be equivalent to the pi, ito yon, which is 1.61 80399. Okay? Another geometrical figure that is commonly associated with pi is the golden rectangle. No? This rectangle or particular rectangle has sides A and B that are in proportion to the golden ratio. Ano yung rectangle na yon? Ito yon. Dito, ito, rectangle. No? Mamaya, papakita natin yan. So, it has been said that the golden rectangle is the most pleasing rectangle to the eye. If we take the isosceles triangle that has the two base angles of 70 degrees and we bisect one of the base angles, we should see that we get another golden triangle that is similar to the first. If we continue in this fashion, we should get a set of whirling triangle. So ito yon, no? Out of these whirling triangles, we are able to draw a logarithmic spiral that will converge at the intersection of the two blue lines. At itong spiral na to, no, ay makikita daw natin sa nature, no? Katawan ng shell, no? And then also sunflower and also yung cone shapes nitong plants na to, okay? The spiral shape represents the logarithmic spiral, no, that is commonly observed, no, in nature. So ano yung sinasabing golden ratio? The mathematics deals with harmony. Harmony is the balance and order within a system. It is a beauty, quality that is present in a thing or person that gives intense pleasure or deep satisfaction to the mind. The pleasure may be arising from sensory manifestation, a shape, color, sound, a meaningful design or pattern, or something else, as a personality in which high spiritual qualities are manifest. The attraction that one has is independent of the ratio one sees. The ratio is of high degree of proportional. So, ito yung reason, no? Kung bakit may mga tanawin na tayo ay nagagandahan at di natin alam, no? So, ito yung explanation nun. Okay? So, nasasatisfied tayo dahil ang tinitingnan nating tanawin is sumusunod siya kay golden ratio. So, dahil dito, ginamit ito ni Leonardo da Vinci, no? Sa pagdodrawing ng mga human bodies, no? Which emphasize its proportion. So ito na yung golden ratio, no? In relation to the golden ratio, John Kepler said that geometry has two great treasures. One is the theorem of Pythagoras, and the other the division of the line in extreme and mean ratio. The first we may name as a measure of the gold, the second we may name as a precious jewel. So dito galing yung golden ratio. Okay, the golden ratio or the golden number or the golden section is defined by dividing a line segment AB. Ayan, ito yon, line segment AB equals A by the point C. So, dinivide natin yung segment na yon by point C. As shown in figure 1 into two unequal parts, X and Y. So, X and Y, may notice nyo, mas malaki si X kaysa kay Y, such that Y is less than X in such a way that the ratio of the larger part X to the smaller part Y is equal to that of the total length X plus Y equals A to the largest segment of X. So that is AC over BC equals X over Y equals AB over AC equals X plus Y over X equals 1 plus Y divided by X. So yung isang X makita nyo dito, no? So kapag ina-down natin, ito yung larger part ng X. Okay? At ito yung other dimension niya, yung katapat na line, which is nahati din ni point C. On the other side, si point E naman yung humati sa dimension na ito. Okay? The golden ratio is a product of early Greek mathematics, which saw the development of related concepts of ratio and proportion, which is equal to, so hindi ko na-explain yung derivation, yung final formula na lang natin, no? Which is, the exact value is 1 plus or minus the square root of 5 over 2. Okay? So yan ang ating golden ratio according to the ancient Greeks. So yung Fibonacci sequence or the golden ratio can also be derived from Pascal's triangle, no? By adding the numbers in Pascal triangle diagonally. So diagonally, paano daw natin makukuha si Fibonacci sequence dito sa Pascal's triangle? So we have the first shape 1. So we have 1 there. So so ang titingnan nyo lang yung madadaanan nung hexagon, no? Na hexagon. So in this first line, nadaanan niya isang 1 lang, no? Na hexagon. Dito isa din, no? Ito lang nadaanan niya. So 1 din siya. But here, dalawang 1 ang nadaanan niya. We have 1 here, 1 here. So 1 plus 1 is 2. Dito si 1 at si 2 nadaanan niya na hexagon. Okay? So equals 3. And 1, 2, 3 nadaanan dito sa line na to. So 1 plus 3 is 4 plus 1 is 5. Yan, so on and so forth, no? So from the Pascal's triangle, we can derive the what we call the Fibonacci sequence numbers. Okay? So that's it for our prelim lesson, no? So sa next meeting natin, we'll be having quizzes, and then finally we will be having our major exam.